Hello, I'm Marcel. In this series of videos I'm going to show you how to use the new project reactor and Spring Boot to create reactive applications. The first thing we need to do is to access the start.spring.io when we can generate our skeleton to have our reactive application. Once you load this page, start.spring.io, we just follow this assistance here to generate our project. So here I will just leave as a Maven project using Java. Spring Boot at this time is 2.1.2 is the latest version available, so I will just pick it. Here in the group I will replace this by any domain, in my case com.casale, and the artifact I will call just Webflux. That's how we call this reactive project in Spring Boot. And here in dependence, the only thing we need to make our reactive applications are using the project called Reactive Web. So be sure that you select this Reactive Web, and that's the only dependence we need in order to generate our project. And just click Generate Project. We will download the file, call it webflux.zip. Once you have this file downloaded, I'm going to use IntelliJ to load this project. So first of all, be sure that you are unzipping the code. So I just did it. So now I have my Webflux directory here. So I will open my IntelliJ. Feel free to use the IDE of your preference. Here in IntelliJ, I will just open this project. So click Open. I will select the folder and click Open. So IntelliJ is going to load the project. This may take a few seconds because it's resolving dependence and downloading some files. So if you are use it to the regular web Spring Boot, you'll see that what we are going to do here is really similar. So it will be quite easy for you to understand what's going on. So it's just finishing here to index the files. Probably we have access to the source code. So if you just open our pwn.xml, you see that's everything generated. We have our Spring Boot using Java 8 and our Spring Boot starter Webflux, that is the one responsible to use the reactive stuffs. So let's start from the very beginning, where you have the impression that nothing is going to happen, but then I will explain the chains. So here in the source main Java, I will create a new package. So right click here, new package. I will call it controller. And then I will create a first controller here, so new Java class. I will call it number controller. Once we generated this file, what we need to do in order to have our REST controller is annotate with this annotation REST controller. Exactly the same as the standard web applications in Spring. And then let's just create exactly the same API as if we are using the regular web package in Spring without the reactive stuff. So I will just create a simple method here, public integer number, and this method is only going to return the number 10 in this example. I will notate this method with getMapping, and I will give a name to this endpoint, and it will be number. So we did exactly the same as a regular application. I will just run this. So since there is no difference, that nothing is different here, but when we start this application, you will see the first big difference, and the first big difference is related with the web server. So the reactive doesn't use the Tomcat or Jetty as we are used to do with regular applications. On the other hand, it uses Netty, that is event-driven server. So if you go here to this URL netty.io, you see that this server is the one that's going to be replacing the regular Tomcat. So you see Net is a synchronous event-driven network application framework for rapid development of maintains high-performance protocol servers and clients. And here's the biggest difference, because Tomcat is kind of blocking, so it blocks all of the requests. On the other hand, Net allows you to work similar to the Node.js, so it has the ability to process asynchronous requests in this event-driven form. So if we come back here to our IntelliJ, we'll see that the application started. So we have Spring Boot 2.1.2, and you can see here that Net started and not Tomcat. So this is the biggest difference. When we just run this, you will see that nothing is going to happen. So we are here in the port 880. So if I just open a new tab here and type localhost 88/number, we will see the number 10 as expected. And you see that you can work in this same way as you are used to, but replacing with Net, but at the same time we're not using the features that the Net and the reactive programming can provide. So let's create another example, but now using some reactive stuffs. Here I'm going to create the same method. So I want to return a single response to the server, and when we just want to return a single response, we need to use a class type called mono. That's why we're going to declare our method as public mono, and then we need to say the type, in our case integer, and I will call it reactive number. Okay, so now we need to return a mono type. We cannot just return the integer, because we need to encapsulate this in a mono instance in order to make the reactive communication between the server. Just to clarify, mono is part of the project reactor, so I'll show you. If you go in the web browser and type projectreactor.io, so as you can see here is a reactive library for building no blocking applications. So when we use the reactive module into our Spring application, we are making using of the project reactor. That's the one that Spring decided to use in its implementation. I would say that the most popular one would be the Reactive Java, but for some reasons the Spring developers decided to use the project reactor. So we will see a lot of classes from this project reactor. I'm not going to get into details on how Project Reactor works in depth, because I would need maybe one hour or even more to explain all of the features it has. But at the same time, I will explain what we're going to use in our application. So I'm going back to our IntelliJ, and let's see how can we provide this mono instance back to our response. So we can easily do this just with return mono dot just. Instead of 10, I will use 20. And of course we need to create our get mapping here, and I will name it of reactive number. Cool. Then we can restart our application and see what happens. So if you are used to the Reactive Java, you see that these operators like just or how you create observables, they are exactly the same, but we need to use the project reactor syntax. So to know more about all of these stuffs I'm using here, you will need to read the documentation and see what are the options in order to make this sort of calls. So here we are starting the application. So it's done. We can just come back here to the browser, and instead of number, I will call reactive number, and then you see that we get the 20. So at this time we are doing a reactive call, but you cannot really see its advantage at this time because we're just returning one value. So we are facing some performance or optimizations using this mono, but it's not something that is really clear for us to see. So in order to make it possible for you to see exactly what is happening, I'm going to create now a stream of data. So this is really interesting because at this time you will be able to see the difference in between the regular web request and the reactive one. So let's come back here to our controller. I will create a new method now in a regular web request. So I will make a public. At this time I'm going to return a list of integers. So I will call these numbers, and I will implement like this. So I will create a list of numbers. So new integer. I will say that it contains 10 integers, and then I will just create a simple for loop here. So I will iterate 10 times with this for loop, and for iteration I'm going to add on each position the number. So I'm going to do I plus 1 because our for loop is starting from 0, so I want the numbers 1, 2, 3 until 10. And to make explicit the advantage in using the reactive form, I'm going to provide a thread dot sleep. I will do for half a second. Okay, so here it's going to complain about the exception, so I will just throw interrupted exception. It's not the best way to handle it, but for our example would be fine. And after the processing, I will just return my numbers array. We need to also add a mapping for it. So I will call it just numbers, and that's it. And I will restart the server. So what's happening here? We just create a new array of integers of size 10, and I'm going to add the values from 1 to 10 one by one with a sleep of half a second in between. So you will see that this endpoint is gonna take 5 seconds to run because we have 10 elements to add in the list every half second. So the application started, we can go to the browser and just run here the endpoint numbers. So you see that it keeps loading, we don't get any response. Just after the whole processing, the full processing after the 5 seconds, we get the response with the 10 values here. So what about if it was possible to return these values as long as we have it? So we could get a stream of data, and we don't have to wait to the full processing to get the response back. And this is what we're going to do now with the reactive programming. So we're going to create a new method. I will call it public. Do you remember we use it mono here? Mono means single value. When we want to return a stream of data, we need to use something called flux. So in this case, we are going to say that we are returning a flux of integers. And I'm going to call this method reactive numbers. And the implementation will be slightly similar, but we need to return an element that is a flux, the objective flux, as we did with the mono. So how can we create this in a nice way? We can do return flux. We need to say the type, so integer. Oh, sorry, flux dot create. So we are creating a new flux. As you can see here, it provides to us one object that we can call just flux sync. Okay, and then we can implement this logic inside. So we're going to create the same for loop. So for int I equals, we can do like this: 1 int greater or lower than 10 I plus plus. Oops, it's not int, it's just I. Here we can start with 1 and we don't need to do this step, but in the previous one we needed because we were using the 1 as 0 as an index here, but we don't have this problem to the second one because we are just returning the integers directly to the client. So we are going to use this flux sync to send events to the web browser. So flux sync dot next, and we just say the integer we want to notify. And of course we're going to do the same thread sleep of half second, and we need to handle this exception here. So in this case it's better just to handle it here. Okay, so I will just handle it inside. Because we are inside the lambda, we cannot just throw here, so we need to catch this exception inside. I'm just doing this, and after all of this processing, you need to notify the client that you finished with your processing, so we can just call something from fluxing, call it complete. So what is happening here? We are creating a flux, a string of data, and then we are iterating over this for loop from 1 to 10, and for each iteration we call the next to send an event to the client, and then we just do a thread sleep of half second, and after all of the processing we call flux complete to say we are done with our processing, we don't have nothing to send back. And then of course we need to create a mapping for it. In this case we need to set a header, so we need to use this value to define our path. So reactive numbers will be the name, and we need to define a header saying that we are producing a text string. So we just say produces, and we just call here text event string. So we are explicitly saying to the consumer that we are sending um, one event string back, and then we can just restart our application, and you'll notice that when we run this application called this endpoint, we are starting getting the information as long as we have it available. So we will see the difference now in between both implementations. So let's just wait here to see the web server starting. Okay, it started. So let's go to the browser and call the reactive numbers endpoint, and look what is happening. We are getting the data as long as we have it. So it, it took the same amount of time, but at least we started get the information as we have it available. So you can start displaying to the customer, you can give a better experience, and you can manage better the resources you have in your server. But it's not the best thing to implement it. There's another way using router functions that I'm going to show next that can make even better how we create this flux or these reactive endpoints. So the next video I will talk about the router functions.